Alrighty, CNT140, Chapter 10 on install. We're going to pick up where we left off last one. They remind us about longer pulls. So longer pulls, this is showing kind of the intermediate. I might pull and then pull and then pull. So the long pulls I might do that way, or I might do this way. I might pull, do the figure eight here in the middle. We'll talk about that in a second, and then pull again. Or I might even do pull from here that direction, pull from here and go that direction, then splice in the middle. I might go that route as well. But for the long runs, they remind us about the figure eight. I pull the cable, lay it on the ground in a figure eight, I flop it over and then continue. And that minimizes the chance of twisting. So here's what you do. You pull the cable and you pull the excess on the ground and start laying in giant figure eights on the ground. You then roll this pile over and then continue pulling the next direction. And what that does is it gets rid of the chance of the cable twisting as you pull it on the next leg. They remind us about the bend radius, making sure when we're pulling we don't exceed the 20 time cable diameter when we're pulling, and then 10 time the cable diameter when it's done. I need to watch my bend radius as I'm pulling. They remind us if I'm doing cable between floors, I should drop from the upper floor down to the lower floor. That reduces the stress on the cable. And then also making sure I have service loops. Okay, and they here remind us about using the cable ties. I'm not going to use the tight cable ties. I'm going to use the Velcro cable ties. Here's that Kelman grip that I might use for pulling by the jacket and or dropping from floor to floor to reduce the stress on. Cable trays, they remind us, I show you two different examples here. I might do the copper in this one. I might do the fiber in the upper one. I might do the copper up here. I might do the fiber in the lower one. But I want to make sure I don't have the fiber in the same tray as copper unless it's protected. I don't want to have a lot of cables on top. Here is interduct that I could install in part of the tray, copper over here, fiber over here, and put the fiber in the interduct for protection. And they do make interduct that has multiple little conduits in so that I could pull one now and have spaces to pull other fibers later. And they do make this style too. I think they talked about this earlier in this chapter, might be last chapter, where inside the conduit there's these little mesh bags, and each little mesh bag allows you to pull a run of fiber through, and it kind of expands as you need it and kind of collapses down as you don't. So it's not the hard tubes that you have on that style. They are sensitive to compression and crushing. So again, with cable ties, I want to make sure I'm using the Velcro style, not using the hard plastic pull it tight style. I don't want to damage the fiber in any way. As I'm going between floors or between rooms, I might need to be doing my fire stopping. I'm showing you a couple different methods get used here, but as I go through walls and floors, I'll need to make sure I'm putting my fire stopping in. They'll also remind us again about grounding and bonding. Not too much fiber optic has grounding issues, but if I have any kind of armoring or shielding, I do need to ground that. And then in our closets, I usually have a ground bar that would be attached to. Splicing, they remind us, is usually done a splicing trailer. The trailer itself might be pulled right up to the job site. It might be a trailer, might be a truck. But inside there's usually counters and kind of a clean room type environment to splice the cable. I just need to make sure there's enough cable at the end of a pull that I can pull it up into the trailer to do the splicing. I might even need to do up on a bucket truck, and I think I showed you a picture earlier of like an umbrella over top of that for protection. Some will actually set up a table near where they're terminating as well, so they have a space to put all the equipment out on. The splicer and the cleaner and the wipes and those kind of things, the cleaver, just like we were doing in the lab room. I slid a table over to do that. After splicing and terminating, outside plan, I'm probably going to run an OTDR test to check that splice and make sure it's okay. If I need to fix it, I can fix it right then and there. The splices themselves will need to go into some kind of enclosure to protect the splice. Here's a splice tray in this box that each splice is kind of going in its own little line there. And here I have a stack of trays. Each tray has a handful of splice in, and they stack on top of each other like a sandwich. So there I might actually be doing in a tray. Outside, I might be using a pedestal. I might be using an underground vault that has a splice protection here. The cable goes in, all the splices are protected there and sealed up for watertight. In a pedestal on the ground, sticking up in the air, if you will, or in the ground in kind of like a service vault. And the utility cover goes on top, screws down, and protects it from moisture and damage. As we come inside a building, again, service loops behind equipment, but I might actually set up a little splicing table as I get rid of the outside jacket and start working on the inside jacket cable, if you will. If it's under construction, if the building's under construction, dust can be an issue. We need to clean everything thoroughly, making sure that I'm not adding any dust to the terminations. Terminating single mode fiber, you're typically fusion splicing on pigtails, but you can do direct termination on 900 micron buffered multimode fiber. This is what I did in the lab room with you. That's just what I showed you in the lab room. Splice on connectors don't usually require a tray or enclosure. They can literally just plug right in, but other stuff might need that tray protection. Some of the other fibers we're dealing with might need that. After doing each termination, you should inspect the termination with a fiber microscope, again making sure there's no light source on the other end. I might even test with a visual fault locator to make sure, I probably should test with visual fault locator, Mr. Brown, get with it, to make sure that that termination is okay and there is no issue with that splice on connection. And then after it's in place, I'm testing with my optical loss test set, looking for my loss measurement, just like we did in the lab room. Usually the installer who terminates the job has the job of labeling each termination and maybe even doing the testing and documenting of that test. So we're looking at color codes, we're looking at labeling, making sure they understand how we're labeling things or color coding things. And again, there's various options to do that, but we just need to let them know this is the plan, this is what should be done. As we're terminating, we need to make sure we clean up the job site carefully. That includes our, splice scraps here for our fiber scraps, and those need to be sealed up and accounted for and disposed of correctly. Excess components should be saved for future use, yes, especially for restoring fiber run, put into a kit, extra connectors, extra splicing hardware, those sorts of things that were not used that should be pulled together for the customer to keep at the job site. During the design phase, each cable run had a loss budget on it. After it's done, after that termination is done, we test for loss and compare those numbers. It should be below that loss budget calculation. Typically, the installer is going to perform these: the continuity and polarity testing, end-to-end insertion loss, and then if it's an outside plant, your OTDR test. So the visual fault and polarity, you're using your visual fault locator and connecting to make sure that it does get to the other end, and I have the polarity marked correctly. Send and receive. Then I do the insertion loss test with your optical loss test set, just like we did in the lab room. And I'm going to compare that with my results. And if I'm dealing with an outside plant, I would be using my OTDR test to verify the splice performance, any sort of issues with the splices and terminations along that run. And then we're documenting. We'll need to, it's documented during the design, during the install, and this is where your test results are saved, so we have them. And then we can turn this over to the customer at the end. And remember, our 606 standard is the one that's saying, yes, this is what we should and should not be doing, or basically what we should be doing for documenting for the customer. And then we need to document where exactly this path goes, what path does it follow, and then the test results of that. Put all into maybe a file, I want to say a Google Drive file, but that kind of thing where we can get all the data to the customer. And there is the end of Chapter 10.